Hello, everyone, and welcome to the eighth episode of Cooking with Unity. And tonight we're going to be doing a tower defense game. Now, tower defense is a popular genre right now, and it's actually a pretty simple concept, but they can be rather complex. It's not the simplest game we've done by far, but the main reason I wanted to do it is because I think that we need something that shows off how to use use a click based or touch based user interface, where most of the projects we've done so far are used keyboard for input. So this is going to teach you how to pick objects in the scene and manipulate them, and we're going to do a little bit on not pathfinding but pathing. We're not going to be doing a complex tower defense, so the paths are going to be set. But anyway, let's get started. So, in the sidebar on the social stream or whatever that thing's called, there's a link to get this script here, detect clicks and touches. I'm not going to be going over it right now, but go ahead and add it to your project because we're going to be using it. I'm not sure if it's going to be tonight, but it probably will be. So, how are we going to get started here? So, let's first get our enemies and our basic play area set up so that we can work from there. So I'm going to start with a plane. That'll be our actual play area. And I'm going to... How does the plane set up by default? Okay. So if we just hit play, we'll have a plane. And I'm going to put a light in the scene as well, just so that we have some lighting. Same deal as usual. And we're just going to put it someplace high up in the sky where it doesn't matter, so that it's not in our way. And the plane, we are going to... What are we going to do with this? I'm going to put it 0, 0, 0. And our camera, we're actually going to reposition this time. I'm going to go ahead and assume that Z is... that Y is up in our game, and we're going to have a camera looking down, so we can have some depth to the characters and stuff. So normally the camera is set up for a side view, and we're just going to rotate this down for a top-down perspective. So where's the camera in the scene? So there's the camera. We're just going to click rotate and rotate it so it's facing down. So 90 degrees. We'll probably put a little bit of an angle on it so we get more depth, but let's just get a position first. And we'll just zero it out and then move it up to 10. All right, that's actually probably good. We'll probably want a bigger play area than that, so let's make the plane bigger. So where do we got here? Nope, wrong thing. Let's scale this a little bit so that it takes up more space. Actually, let's make the camera closer first. Oh, that's about right. We'll just do... we'll make it a wide one. So now we have a basic full play area. So we have ground, and we're gonna need units moving. And as I said, we're going to be doing pathing in this. So we're gonna have a path that the enemies go through, and then they get to their end point, and then if they get to the end point, that's a bad thing. You want to stop them from getting to the end point. So let's start with an enemy. Let's start with our first enemies as a cube, and we're gonna create a very basic material for it. We're just gonna do a red material so that you know that they're bad guys. I like really simple color schemes in my prototypes so that you can understand what's going on. And we're going to call this an enemy, basic enemy. And let's see here. So let's move this so it's somewhere in a logical position. And let's see. We're going to move it up a little bit. Probably 5. There we go. That'll put it right on the play field. And what else? Let's start it on the... Do you want to go left to right or right to left? Let's do left to right. So our base will be on the right and you're going to protect it. And so we'll just move this thing over to the left edge approximately. -2, -20, -15. Alright, -10, that's good. Let's see how that looks on the camera. We're just mocking this up right now. Alright, cool. We have a little dude. It's at the edge of the screen, so it's kind of distorted there as a cube, but it'll work. And let's actually go ahead and do that, what I said before about giving it a little bit of a rotation so that there's more depth to the field. Let's go ahead and put it at 80 and move it down an appropriate amount, down being in the Z direction. So let's see what we got. Alright, cool. So we have an enemy, and it does absolutely nothing. So we want the enemies to be able to move, and we want them to be able to move in a slightly more complex way than we've been doing. What I'm going to propose is that we set up goal objects for them, and they'll have just a list of goals to go to, ending in the player base. And it'll move at a set rate between those goal points. So let's create a new script called move to object. And we'll wait for that to open. Actually, I don't like that name. Let's rename that anyway. I'm just going to delete it. Just save me a step. Yeah, I guess it didn't save me a step with all the clicking and waiting I'm doing. Let's go path through objects, because we want it to be multiple points, not just one point. So there we go. And we close these things that are with another project. Alright, so this is going to be pretty simple. It takes a... relatively simple. It takes a list of... an array of game objects. So, game object array, path point, and all it's going to do is just go from point to point. And let's see here. So let's work on working to the first path point first, and then we'll move on from there. So we're going to need a... Yeah, we're not going to want a for loop on this. So we're probably going to need a private variable to say what one that we're going to. Int current path index. And let's see. So we've done this before, where we basically want to move the transform. And I went over in the vector math one a little bit how to do things kind of at an arbitrary angles and stuff. Our first project did just manipulating X and Y, and that's not appropriate for this if we want to do movements that aren't just explicitly X or explicitly Y. So what we're going to do is we're going to do a little bit of vector math to figure out what direction we want to move to, and then a little bit more to actually move us in that direction. So let's start moving us in a direction to our first path point. So our first path point is path point 0. And we're going to be modifying this as we go through the list, but I'm just going to hard code it so that you guys understand what this is actually doing. So path point 0, this is the first element in our list. So let me comment this out real quick so I can show you what actually happens in the editor. If we were to attach path through objects to our basic enemy here and look at it, we have this path points thing, and it has a size. And if you basically, if you drag an object, I'm just going to drag something we are in here, it increases the size and adds that to the list, and then you can add another object in here. Obviously, we don't want it to path to the directional light in the main camera and the plane, but I'm just throwing these in here to show you how it'll work. And the goal is to make it go to this position. Once it gets there, go to the position of this object. Once it gets there, go to the position of this object. And we'll set up waypoints using that. So let's put this back down to 0. Or actually, I guess I should just done reset. So this is a array. That's how you declare an array. And you can access the elements of the array by putting an index in here. So this will return our first path point that's been set, and it'll actually give us an error if nothing has been set. It'll give an index out of range error. So we're going to want to move our transform.position over time to the path point dot position. So I'm just going to comment these so that we know kind of what the goal is, where we are and where we are going. So so what we want to do is we want to figure out where we're going, and so the first step is to figure out where we're going. And so the direction of where we're going is based on vector math, the goal position minus our position. So our goal, let's say current goal, this, we haven't actually declared this, but we're going to in a second. Current goal equals transform dot position, no wait, sorry, path point 0 dot game object, actually game object, wait, no, sorry, transform dot position. I'm off my game today. I even practiced before this one. Transform dot position minus transform dot position. So path point dot position minus transform dot position. So this will be a vector 3. So, and we're probably going to need to save it. So let's make a private vector 3 movement direction. And oh, sorry. Current goal. I guess that doesn't make sense because the goal is actually here. So yeah, we're going to go with movement direction. And we're going to go ahead and put brackets around this, sorry, parentheses around this, and do dot magnitude. And the reason we're doing this is, sorry, not dot magnitude, dot normalized. And the reason we're doing this is if we don't do that, we'll get a vector that's from the point that we're wanting to go to, well, point we're at to the point we're going to. We actually want one that's 1 unit length in that direction so that it's easy to manipulate. And this will give us that. So this gives us our actual direction of movement normalized. And then we can use this information to actually move our object. So the movement code for this will be something along the lines of transform dot position plus equals movement direction times speed. And so we're going to need a variable called public float speed. And that's actually basically our whole movement code there. And because this is normalized, this will just work out for us. So we kind of have some problem with our code here. So this movement direction always goes to our first path point, and it sets it every time. We don't need to do that. But this actually should be enough to at least give us a test run. So let's create a new empty game object, and we're going to call this path point does not exist in the current context. Path points. Oh, plural. All right. So we're going to call this waypoint 1. And we're going to give it a position that is meaningful. And what's our enemy at? 0.5. We'll assume all the enemies are 0.5 high, so we'll make all our waypoints 0.5 high so that we know that we're not going to be moving them in the stupid direction. Movement direction does not exist in the current context. Direction, movement, direction. I must have had a spelling error because that is a different size when I pasted that in, so hopefully that'll work. Yeah, I added an M there. I'm terrible at typing, evidently. So, okay, finally, got rid of all those. So we have our waypoint, and let's make it a slightly more interesting position than I put it in. Let's make it so it's up vertically, well, not vertically, but up in the Z a little bit to see if it actually works. And let's the movement. So if we set this waypoint into our path points, it should go to it, assuming we set a speed higher than 0. Actually, I like to do this just so that people don't think the scripts aren't working. 1.0f. So now it'll at least work even if you forget to set a variable. So we're going to set this one manually there. So if we hit play, hopefully we'll get some movement. Wow, okay, so it moves real fast on that. Oh, forgot a really important thing. I was expecting that to move much slower because I was expecting it to move using time, and I forgot to multiply in time, so we're going to multiply in time. God, my computer's running bad today. What is going on? Alright, delta time. Is this actually being recorded? Like, is everything working? Wow, everything's slow. Alright, yeah, it looks like everything's working. I don't know. Hopefully my computer will survive through this whole episode. So what this does is, before this is just every frame it's moving in the movement direction times speed. Now it's going to move in the movement direction times speed every second. That's all this does, is this gives us a small number to multiply in that represents the amount of time this elapsed since the last update loop. So now it should move considerably slower and smoother looking. Here we go. And that didn't work. Did I not save? I did not. So we're going to hit play. Alright, there it goes. Much slower, much more what I was expecting. We can adjust the speed probably in real time if I can get there before it gets there. Yeah, so... Oh, negative speed, it'll move away from it. That's kind of cool. So, but yeah, we can make it a more meaningful speed. We'll probably start with 1 just so that people have a lot of time to figure out what they're doing. And, let's see. So we have the basic movement, and that's just for one position, but we want to support multiple positions. So, we're going to, have another, we don't need that variable yet. We'll put that in if we need it. So, at the start of this, we want to start at 0. So, current path index equals 0. Actually, let's set it here. So it starts at 0. And we're going to move it till it gets to the waypoint, or very close to the waypoint. And then we're going to change the movement direction stuff. So the very first time this runs, we want to set the movement direction to current path index. That's all we're changing here, so it actually has some meaning. Beach ball. Do you see the beach ball? You probably don't see the beach ball because it's a simulated mouse cursor. Anyway, that's what I was getting. All right. So this gives us our movement direction from the current path index, and that's the initial direction. As a matter of fact, we could probably put this into our start. Start. Should never delete this function because it always ends up being useful at some point. I just have a habit of deleting things I don't think I'm going to use. Come on, give me this whole line. Model development and my computer are just hating me today. Alright, so we have our update. We have our movement code, and so we have that. So this gets our initial start movement, and we need to do a check to see if we've gotten to where we want to be. So if transform dot position, and yeah, we don't want to do equals equals. So the problem is we can't just ask if it's equal to our goal point, because if we did that, there's the possibility that it's very close to our goal point but doesn't actually hit it. So we want to be near the goal point. So I'm gonna go ahead and make another variable here so so we can tweak this. Public float goal. What should we call this? Goal size, goal fudge, I don't know. Position difference, I don't know. We'll do goal area. I don't think it makes much sense, but that's what my brain's coming up with right now. Or goal size. And we'll set this to, I don't know, 0.1 to start and see how that goes. So if transform position is oh, that's not going to work. All right, let's just try equals equals right now. See if we just get lucky. Transform dot position. I know this isn't going to work, but we're going to try it anyway. Path points, current path index, transform dot position. We update our movement direction at this point. So we're going to be doing that. And we're going to be increasing our index for our movement. So current, wait, I didn't spell that right, did I? No, I didn't. Current path index plus plus. This just adds 1 to the current path index, so it'll be 1 the second time through and 2 the second time through. And right now I'm not checking to see if we've reached the end of the array yet, but we'll do that in a second. Let's see if this will even work. I have my doubts. So I'm going to duplicate this, create waypoint 2. And I had another place in here where I use current path. Alright, current path. And waypoint 2 will move to the right a little bit, so it'll kind of go to the right, I guess. 3, we'll move it 3 to the right. And we're going to add it to our enemy so that we have another waypoint. Wait, why did it have waypoint 2 twice? Okay, whatever. So waypoint 1, waypoint 2. So it's going to move to waypoint 1, and it's probably going to jiggle around it. Actually, at this speed, it probably will work, but there's a potential that there could be a problem with it just because we're checking to see if the position's exactly equal. Yeah, it definitely passed it and went on. So the reason it's not jiggling around the point anymore is because we're setting the direction once and then resetting it when we get to our goals. Maybe it would be best to actually do this using the collision system. So let's do that. That'll solve the problem of checking for being near enough without having to do any fancy math. So, yeah, let's change this up. So we're going to make our waypoints have a collider. So we're going to create a little box collider. Actually, let's do a sphere collider. And we'll set the radius to like 0.1. We'll do the same thing on waypoint 2. What is it called? Physics sphere collider. Did I do 0.1 or 0.2? I did 0.1. So now instead of in the update loop, we're going to actually do this in the and actually let's make these triggers, sorry, so that they do not have any physical capabilities. So void on trigger enter, and we want to make sure that we get our collider other. So here's where we're going to put our little thing in. And I'm going to grab the if statement too, because we're just going to change it to make sure that it's the object we want. So if other dot game object equals path points dot current path not dot bracket current path index in bracket. So that should be our logic, and let's see if this actually works. And do we have a collider on here? I think we do. Yes, we do. All right, so let's see how this goes. I should make the speed faster for testing this. And it totally didn't work. I probably forgot something. On trigger enter collider other. Let's open up Google, a new window, I guess. Forgot to open up my Google window. Wow, my computer's going slow today. So on trigger enter. I can't believe how slow my computer's going. Okay, taking too long. I'm bored. Man, I hope this video is rendering properly. I hope that you guys are able to follow along on this. So, what's probably not working is this comparison. Let's use the name as the comparison. And dot name. Probably should have put a debug print in there somewhere, but we'll do that next if this doesn't work. And I want to make this thing faster so we can test this faster. Speed 5. Yeah, still not working. So waypoints are in the path, right? Yeah. They have a sphere collider. It's a trigger. Alright, fine. Let's see if it's actually even getting in here. Debug.log other. We'll just see if it will print out what we're colliding against. is it doing? Let's actually look at the scene and see if it's like moving in a way that we don't expect it to. No, it looks like it went right through where that thing is. Let's make the trigger bigger, I guess. Make sure that we're hitting it somehow. Did we get a console on that at all? Oh, duh. Okay, got it. In order for that to work, I think our basic enemy has to have a rigid body of some kind. So, physics, rigid body, and we're going to make the lamest rigid body in the world. We're not going to use gravity. Actually, let's see if it'll work with the kinematic. It may. Hopefully it will. Okay, it worked. It totally worked. Didn't work as smoothly as I wanted, but it did work. So there we go. We needed a rigid body attached. Sorry about that taking so long, but that stuff happens. So now we gonna get rid of our little debug thing because that actually worked. The other thing I'm gonna do is I'm just gonna go ahead and make it. We're gonna make the collision area real small on these again, and to make it look like because we have our next waypoint just to the right of it, and we want it to look like it's moving nice and smoothly to the right. I'm gonna have it actually set our transform dot position to the original goal point, which is path to points, current index, transform position stuff. Alright, so this should make it move nicely to the right. And you'll see that we got an index out of range exception, just as I said we'd have as soon as we hit the second object. So we got the first and then we got the second. So there we go. We have an object moving. We can do kind of a path thing. We need to actually check for the other options. I'm going to make the enemy slow again. So we're going to make him... Let's do it 2. Let's just see how that feels. Yeah, that's good enough. Alright, and I want this thing to look... This plane needs to look better. We should have a texture on here. We'll have texture later. So we have an object. We can move it to multiple waypoints. Let's create a third waypoint for fun. And let's put this where our base will be. So somewhere at the right side of the screen. Where's this one at? -10. Let's make waypoint 3 at +9, and in the middle somewhere. Still at 0.5 though. So there's our final goal. I'm actually going to call this base. That's descriptive enough. Let's call it player base. That can mean a lot of different things, but whatever. And we are going to add it to our enemies little waypoint list. So, why is it... Oh, I guess I'm renaming the wrong thing. So, waypoint 2... Let's lock this so that we can actually drag these in easily. Waypoint 2, and then we want player base to be the third waypoint. And we'll just make sure that this still works. So we have a really, really basic pathing system here. So it goes to that position, it goes to the next position, and it goes... Wait, why did it... what did it collide with? Oh, waypoint 1, waypoint 2. Oh, yeah. Yeah, let's make these a little bit further to the left. See how that looks. And we currently aren't drawing the path on the screen. We'll do that later so that we can communicate to the player the way these things are going to go, so that when they place their objects, it'll make sense. And also so that we can what is it called? Make it so that they can't block things, and so they know what they're going to be shooting at. So we have our basic pathing. And so we need to have some objects that can shoot at it. Let's look at actually adding click capability to this. And I just realized that the function I have here that I've given you guys, we're going to modify it, make it even cooler than it currently was. Let's go over this. We're going to add the ability to click and place structures. We're not going to have a menu to choose the different structure types yet. We will do that probably in a future episode. But we'll just make it right now so that you can just click and place things, and we're not going to worry about the amount that you can place. So just get some towers down. So let's do that. Here's our detect clicks and touches script. Again, you can download this on the link on the right in the social bar, and it'll be in the description of this episode once I've finalized that. So, God, it's still going so slow. I wonder what's taking up all my CPU. All right, so this script I already wrote, and I'm providing it for you. It's free to use for whatever. It's not under any particular license. I'll do that if the license police want it under something. But just feel free to use it. And it's pretty simple, and it's pretty generally useful. Basically what it does is, as it describes here, it makes it so if you click anywhere, it will get the object that you clicked and give that object a message clicked, so that you can run some logic on that object. So what it does is you can set a detection camera. I have this in here because sometimes you have a UI camera separate of the main game camera, like we did in the for the reticle in the puzzle platformer we did before. And if you don't set this, we automatically in the start menu, in the start function, set our internal camera variable to the main camera. So you don't even have to worry about setting it, but if you set it, it'll use that one explicitly. And the reason it needs to know this is because it's setting up a raycast from the camera through the scene to see what object has been hit. And so what this does is, let's look at the mouse version first. So we have this if application platform stuff. This is just so that this will work on iPods and Android devices as well as computers. So let's look at this is if you are on a computer. So I'm going to comment this a little bit. Else we are on a computer, more than likely. I say that because it's an else statement. It could actually just be anything that's not Android or iOS. So we're checking to see if the left mouse button is down. That's all this does. Check. And I'll re-update this script with these comments once we're done. Check to see if we've clicked. So this ray is used in a raycast, and screen point to ray basically takes whatever position that you have on the screen that you've clicked and automatically figures out a ray that goes into the scene appropriate to the field of view and everything that will hit objects as if you were touching them. So this sets that up. Actually, let's do this above. Set up array from screen to scene. If we hit this is a little debug thing. If you have debug selected, it'll tell you what you clicked. And so tell the system we clicked something if in debug what we clicked. And this is just a variable I set at the start, so there's probably a fancier way to do this, but yeah, we just default it to false. But you can turn it on and you'll get messages, and it'll just say you clicked and what you clicked, and it also gives you a reference that'll show you how this works, so that if you click the message, it'll show you in the hierarchy what was clicked. And then this is tell run the clicked function on the clicked object. So hit.transform.gameObject.sendMessage. So this is what we clicked on. This is what we're sending it. And this is a function call, basically. And it has the options don't require receiver. And the reason we have it that way is so if you click on something that doesn't have a clicked function, it will just ignore it. It sends the message, but it won't complain that nothing picked up the message. And that's basically how this works. It's pretty simple when you get down to it, but it's screen point array is something we haven't done before, and I had it preset up this way just because I didn't want to go through this and kind of had it set up wrong. So, and the other reason is because I have this section here, and this supports touches, and the only thing fancy about what it does for the touches is it does it for every touch. So if you have a finger on the screen and you touch something, it'll collect a message. If you touch something and then touch something else, they'll both get clicked messages, even if you haven't removed your fingers from the screen. And that'll work for our purposes, and honestly, it's usually what you want, but there may be special cases to that. So this thing goes on any object in your scene. It doesn't matter what. I'm going to put it on our camera because we know we're going to have a camera. And actually, while I'm thinking about it, I'm going to save this scene so that we don't lose any progress here. I should have been doing this more often considering how bad my computer is acting. So I do hope that every time that beach ball comes up, I'm not dropping out. Main level or test level. And so now we have a level. And we connected this to our main camera, right? Did I do that? No, it evidently didn't go on there. Why is it not going on there? Do I have another error somewhere? What is going on? Did this not compile when I changed things? I didn't change anything important, I don't think. Huh. Why did I attach it? Oh. Duh. Alright. So, remove component. We still had, well, you probably didn't, but I still had this locked from a while ago, so it was still showing us the enemy. So, go to our camera. Oh yeah, there's all our detect clicks and touches. Let's make it so there's only one of those. And, oh, that was too many, so detect clicks and touches one more time. And we're going to click debug so that you can see how this works. So we hit play, and if, I'm going to bring up the console. If I click the player, oh, variable detection camera. Oh, wait, what? Camera. Oh. There we go. I had a big problem in that script. Okay, I definitely am going to be updating that script, so don't worry about it. Let's see what we got. I swear I tested that, but I guess I didn't. So, click basic enemy, click the plane. That's all we really can click on. Well, actually, we can probably click our waypoints if we can find them in here. But they're invisible, so it's kind of hard to tell. And they're very small. Alright. But you can see that it's saying we clicked those things, so that means it's working, at least we hope. So I'm going to turn off debug on that. And all we have to do is just have it so when you click on something, it does something. And so on our plane, we're going to set up so when you click something, it does something. It's not going to work in this case though because we really need some position data. So I'm going to modify this script a little bit further and make it so instead of just calling clicked, it's going to call clicked with a position. So I think all we need to do is just put another comma in here. Yeah, object value. So what we're going to put in here is a vector that represents where we clicked. So hit dot position point. Hit point. And we're going to do that up here as well. And that way we can actually get the point. All the projects I've done so far, I've used this for basic menu stuff, which didn't really need that extra information. So, but this time we need it. So hopefully this will work out nicely for us. And hopefully that's okay to do. Hold on, let's see actually. Game object dot send message. Maybe this won't even work. Object value. No, that'll work. That'll work perfectly. So, wasn't sure if it sent an object or just a float or something. So now, let's see if we get any errors when we play real quick and click on things. All right, everything looks clean. So we're gonna have it create objects based on where we've clicked. So we're gonna create a new script that says create tower on click. On clicked. And we're going to attach this to our plane. So now we need to actually make the script actually do something. So we're waiting for this to load. So this will be receiving a clicked command. And we don't really need any of these. I'm probably going to have to put them back later naturally, but so clicked, and we're going to have it accept a vector3 position. So that's where we clicked on the plane, or at least on the collider for the plane. So hopefully this will all work. We're just going to instantiate, so we're going to have just a set tower type right now. Public game object tower. And so we're going to set, we're going to instantiate a tower. Tower at, so where do we want it? We want it slightly higher than the vector3 position we want, so that it's not sticking in the ground. And as I said, we're going to assume that all the objects are going to be at 0.5 highs because they're going to be a certain height. But we can worry about making a more generic case later. So I'm just going to simply do position plus vector3 dot up times 0.5 f. So that'll move it up from where we clicked, and then we're gonna, the quaternion rotation is just gonna be the quaternion identity. Identity just means the initial rotation. And actually, we can probably just do tower dot rotation, so that'll give it whatever rotation we give it on the. Let's try that. Tower dot rotation dot transform dot rotation. That'll be better. And that may be all we need to do. So let's make our towers cubes as well for right now. But we're gonna make them green. So I'm gonna duplicate the red, Command D or Control D if you're on Windows. green, and we're going to make it actually be green. I said actually too many times this episode, I think. But that's okay. So we're going to call this tower. We're going to make it green. And we're going to set its position to 0, 0, 0. And we're going to make it into a prefab. And honestly, we should do this with our enemy too. So we're going to delete the tower. So we have our tower, and we have our plane, and we put our tower into the plane's create tower on clicked script. And if we're lucky, this will just work. So when we click, it just worked. So we can place towers wherever the hell we want. And that wasn't too hard to set up. So again, I'm going to explain kind of how this works. This function clicked is being called from detect clicks and touches, and it's being called using send message. So this is the name of the function, and this is the variable being sent. The variable in this case is a vector 3, so we tell it to expect a vector 3. If we didn't, we might have some problems. I'm not exactly sure what problems, but there'd be problems. So it basically, when we click, it tells whatever object we clicked, it was clicked. If we run this again and we click on the player, or not the player, the little enemy dude, it's not going to actually create anything because it's only creating it on the object that's getting the clicked command. So when we click elsewhere, we get towers. And if we click outside of the game area, we don't get anything. So it's working nicely. And this way we can, if you wanted to block out an area that the player couldn't build on to make interesting scenarios, all you have to do is basically create colliders over the areas that you don't want the player to have access to. And that's nice and easy to set up. So we have basic movement, and we have our tower. Let's make our tower shoot at our little enemy and call it a night. Hopefully we can get this done in 7 minutes. So let's create a C# script called basic tower. And this will be our basic tower AI. And I'm going to go kind of fast on this because I want it to happen. So let's just make it so these things always shoot. So the easy way to do that is we can use something that we haven't used before. And actually, I didn't know about this. I don't even think I knew about this last episode, but there's a command called Invoke and Invoke Repeating. And this allows us to invoke a function that takes no parameters continuously. So Invoke Repeating, and we're going to create a function down here called void spawn bullet. And so we're going to do spawn bullet, comma, 0.0f. That means it'll happen immediately the first time. And repeat rate. We'll have it shoot every second for right now, 1.0f. And spawn bullet is going to look for the nearest enemy and shoot at it. So let's just have it look for any enemy right now and shoot at it. So I'm going to actually create a tag for the enemy. We're going to call it an enemy. So add tag, tags, enemy. And so now we'll go through, call it an enemy. And so now we can game object dot get find game object with tag enemy. So game object target equals. So we're going to spawn a bullet and set its rigid body moving in the direction of the target. So we're going to need a bullet public game object bullet. And so new game object new bullet equals instantiate bullet at our tower position. So basic tower, transform dot position, and we need rotation, so we'll do again the bullet dot rotation dot transform dot rotation. And then we're gonna just assume this new bullet has a rigid body on it, and we're gonna apply a force. So new bullet dot rigid body dot add force, and we'll just give it the vector to the target. So again, target dot position, no, transform dot position minus basic tower, was it bullet, and we'll also do public float bullet speed, and actually let's make it public float fire rate, and we'll use that in, set both of these equal to 1.0 f. Gonna go a little over on the time, but that's okay. So we want the fire rate here, and transform to minus transform dot position, and we'll normalize this again. Normalized times bullet speed times time dot delta. No, we don't want that. Times bullet speed. All right, and yeah, that should be all we need to do. So one problem with doing the invoked repeating thing in the start is you won't be able to real-time adjust the fire rate and bullet speed stuff. Well, the bullet speed you can, but the fire rate you can't. It's not a big deal, but just something to keep in mind. And we're not going to worry about the collision portion of this. We're just going to make sure that this actually does something. So where's our tower? We're going to attach a basic tower script here, and cannot implicitly convert type. Oh, as game object. And I wait for my computer. Play the Jeopardy music. I've got a beach ball. Waiting on the beach ball. Is there something I can do here in the meantime? Oh, come on. Alright, is it not responding? Oh, my computer is just hung. Not in the good way. Give me the force quit menu. Give me any menu. I hope this is... Oh, there we go. Force quit. Come on. No, don't relaunch Finder. What is going on? Alright, it's back, finally. As game object. I am so going to restart my computer before the next Cooking with Unity. I thought I did it today, but I guess I hadn't. Alright, so let's see if this works. All compiler errors have to be fixed. Oh. Put the as game object in the wrong line. So, there we go. Evidently it was a line that didn't matter. So here we go. Let's see. Tower has what attached to it? Does it have the script? No. Yeah, it does. Alright, so we need a bullet. So let's create a small sphere. Let's do a sphere. And let's make it 0.4, 0.4, 0.4, 0, 0, 0, and let's make them yellow. So duplicate and call this yellow. Make it actually yellow. Actually. And we're gonna call this bullet. We're gonna make it yellow, and we're gonna throw it over here. And then we're gonna get rid of it. And so now if we place our objects... Oh wait, I didn't actually set the bullet thing yet. Oh, come on. What are we waiting on? Alright, so it's working, but we want the tower to actually have a bullet. And because I want this thing to fire faster than 1 second, I'm going to do 0.1. We'll make it a rapid fire thing. And we'll make the bullets move at, because the units are pretty small. Let's do 10 and see how that does. We're going to be doing this as a... Oh yeah, and we need a rigid body. Sorry, one more thing. On the bullet itself, once my computer is done whatever it's doing, I really hope this is recording well. Alright, so what is it that I was doing? Oh yeah, we want to actually make it so the bullet has a rigid body and that it ignores gravity. So we put our tower down. That's probably because our towers have collision. Let's actually make those towers be tag collision. Actually, do they need collision at all? No, they don't. We're just going to get rid of the collision for right now and see if this works. Okay, so I think it's spawning them too quickly. It's doing some interesting stuff, isn't it? It's either spawning them too quickly or they're not moving fast enough. Let's make them move faster and make it spawn less, and we'll see how this goes. Bullets... No, sorry. Tower. So let's make them spawn once every half second, and let's give this 100 power to the initial velocity. At least it was doing something. There we go. It's shooting to where the enemy used to be rather than where it is. And let's actually change the scripts very slightly and call it a night. I'm just going to change the way that we're doing the force thing. So add force can have a second aspect with it, which is a force mode. So let's do force mode velocity change, which what that means is it ignores the what is it called? The mass of the object in the calculation. So this should make them shoot a little bit faster by itself. Yeah, considerably faster. Too fast even, it's not even colliding with it. So now it'll actually be closer to the speed. Like if we set this to 1, it should be, or set it to 2, it should move the same speed as the units do themselves. Let's just test that theory. Yeah, it's looking like that. So that's a good deal. And oh, I see what's happening. It's because the initial one's going too fast on the basic tower. So let's try putting fire rate in both these. Let's see if that fixes that initial problem. Try something and try something else. So it's working. They look like they're moving about the same speed, so that's good that we're using that force mode thing. It means that these units will correspond. So we want it to move, let's say, 10 times as fast as the little cube does. And there we go. They're hitting the cube. We don't even have to delete it because they're firing fast enough. Alright, so we have the basics of a tower defense game started, and we're only 7 minutes over. Thank you for joining me tonight, and sorry about the computer troubles. Oh yeah, contact me at, I'm not going to pull up the text, pushypixels at pushypixels.com. That's PUSHYPIXELS. And you can also find me as Drakfyre on Twitter. That's DRAKFYRE on Twitter. Anyway, thank you very much. Good night.